Good morning. Welcome back with 10 day 2. Today we're going to continue with our review. Well, today's review is about the systems of linear equations, okay? So we got 2 exercises in here. The first thing that we need to remember about systems of linear equations is that we have 3 possible answers. Which ones are they? Do you remember? What are the 3 possible answers that we can have?
Infinitely many solutions, no solutions.
No solution, and one solution.
One solution.
Exactly, and one solution. Those are the 3 types of solutions that we can have. In these 2 particular exercises, we will get the same answer, I think. I don't remember. Now, before that, I'm going to give you a little hint before we continue. A little hint. When are we getting no solution? This is just for you to observe the equations, look at them really careful, and determine without solving anything yet if it's a no solution, okay? How do we do that? Okay, we go ahead and find the slope of them both, okay? If they have exactly the same slope, then it is no solution. Remember, in order for you to find the slope of an equation, the equation has to be written in slope-intercept form. In this case, all 2 exercises have their equations in slope-intercept form. Other word, the variable y is completely unknown and positive in one side. If they have the same slope, if the same coefficient of x is in both equations, then that is a no solution. We got it here. Negative x, meaning an invisible one, negative 1, and negative 2. Are they the same? No. So this exercise will not be no solution. It is either infinitely many solutions or one solution, okay? But it's no solution. 4x and 3x. So 4 and 3, they're different. Therefore, this is also not a no solution, okay? Now, second hint, if the equation is exactly the same slope, same intercept, then it is infinitely many solutions. So they're not the same, so they're not no solution, and they're not infinitely many solutions either, because this is a negative 2 and this is a positive 4. So if they do not have the same slope and the same intercept, they are not infinitely many solutions. So this will be a one solution. Now this one, it doesn't have the same slope and it doesn't have the same intercept. So also this is not a no solution and not an infinitely many solutions. Again, this exercise will be a one solution. Okay, that is just for you to know how to identify how many solutions it will have, okay? But I do need to see the procedure. So how do we solve a system of equations, of linear equations? How are we going to be solving it? We will be solving them with the standard form method, which is the intercept methods. Even though they're written in slope-intercept form, we're going to be using intercept method, okay? The intercept method is when we find the intercept in x and the intercept in y of each equation, and we graph them. It will be 2 points graphed in the x-axis and 2 points graphed in the y-axis. So the first step is to determine one of the equations being called equation 1. In this case, I want this one to be equation 1 and equation 2. I want the second one to be called equation 2. It doesn't matter if Valentina wants them to be the other way around and Valeria wants it this way. It doesn't matter, okay? Because at the end, what matters is the way that you graph it, okay? So this is the first step, determining which equation is equation 1 and which equation will be equation 2. So now we copy equation 1. Y equals negative x minus 2. and I'm going to look for the intercept in x. And what is the intercept in x? The intercept in x is when I need to find the value of x, but y will be equal to 0. So I'm going to substitute that y to 0 in my equation. So 0 is equal to negative x minus 2. I need to have the variable x completely alone and positive, so I'm going to pass it to this side, to the left, positive because it's negative, right? So I'm going to have that x is equal to negative 2. And that's the number that I'm placing over here, negative 2. Now the other one, intercept in y. The intercept in y is when I have x equals to 0, and I'm looking for the value of y, okay? So I'm going to place 0 instead of x, so I have y equals negative, because the equation has a negative, instead of x, 0 minus 2. And I don't care that I have a negative on the outside, I cancel that as well, because 0 multiplied by anything, even by a negative sign, will be 0. What do I have left? Negative 2. This particular case, we got exactly the same number, negative 2 in both, but they are a different point. Remember, one is the x-intercept and the other one is the y-intercept. I finished with that part. Now I'm going to do equation 2, exactly the same procedure, but with the second equation. Y equals negative 2x plus 4. And just remember that it doesn't matter what intercept you find first. You can find first the intercept in x, or you can find first the intercept in y. So for this one, just for you to see that it doesn't matter, I'm going to find first the intercept in y. I'm just going to be careful that I know that the intercept in y, x is equal to 0. I don't place it the other way around because that won't be the intercept in y. That will be the intercept in x. Okay, so I substitute x over here, and I got the y is equal to negative 2 instead of x, 0 plus 4. And 0 times anything is always 0. So I cancel that out, and I have the y is equal to 4. And that's the value that I'm placing over here as a y coordinate. Now the intercept in x. Again, I need to be careful and remember that I'm doing it in the second, but it means that y is 0. So 0 is equal to negative 2x plus 4. And that 0 does not look like a 0. So let's close it there. Now I need to leave the variable x in one side positive. So I'm passing it to the left because it's negative. So I'm passing it positive. I have 2x is equal to 4. I need to leave it completely alone. So the 2 goes to the other side, dividing because it's multiplying. In this case, it's positive, so I keep the sign positive. So it's going to be 4 divided by 2. So x is equal to 2. And that 2 is the one that I'm placing in here. So you see, sometimes it's a coincidence that you get to have the same number as a solution, even though they're in different positions. Sometimes we've got a different number as an intercept in x, as intercept in y, okay? Does it matter? No. Does it matter which intercept you get first? No, it doesn't matter either, okay? Now we're going to graph. So I'm going to move this higher over here, and I'm going to move this to this side. There, I'm going to graph it there. So we need the intercepts. There we got. For the blue one, negative 2, 0 on the x. So negative 2, 0 is over here. And 0, negative 2. So down here. I'm going to connect those 2 points with a straight line, and I'm going to extend it a little bit on both sides, okay? So remember, it is a straight line passing through the center of both points. So I'm going to extend it like a little bit exaggerated over there. And now I'm going to go to the other side also extended, okay? Afterwards, I'm gonna place the arrowheads, okay? After that. Right now, I'm gonna leave it like that. Maybe the arrowheads in here. Now let's go with the green one. For the green one, we need to graph 0, 4 on the y. So 1, 2, 3, 4. Oh, green. And 2, 0 on the x. So 2 is over here. I'm moving this so I can graph it properly. And I'm going to connect those 2 points with a straight line passing through the center of both points. And you see, that's why I needed to extend it, okay? Because it gets outside the coordinate plane. So I'm going to extend this to the other side because I didn't extend it. And I'm going to do my arrowhead over here. How many solutions do I have?
One solution.
One solution, kind of in there. So I'm not asking on the exam, what is the solution? I just want you to tell me that it has one solution. And we knew from the beginning that we were gonna have a one solution. Yes, Angel?
We have to prove it.
No, I just said it. We don't need to prove it. I'm just asking what is the solution. Yes, Dennis?
We can know if it's one solution or no solution. Before graphing it, we can skip the graphing in the exam or not.
No. It is just for you to help you out to determine ones that you graph it. So maybe you graphed it incorrectly and it gave you no solution, but you knew it was one solution. So you need to fix your graph, okay? The graph cannot be skipped. You do need to graph it, okay? So that is the first exercise. Any question about the first exercise? No? We're good? Okay, let's go with the second exercise. What is the first step in this exercise? What is the first thing that I need to do? What is the very first thing I need to do in this exercise for me to solve it? What is the very first step that I need to do? Let's see, Valerie. What is the very first thing that I need to do to solve the exercise? Huh? Let's see, Natalie, maybe you can help Valerie. Let's see, Valeria. What is the very first step that I need to do? Siloe?
See if the slope are the same to see if it is not a solution, and the y-intercept, if are the same, is an infinite solution.
Okay, but we did that already. We know that it is one solution. We did it from the beginning because 4 and 3, they're not the same, so it is not no solution. And since 4 and 3 are not the same and 1 and 2 are not the same, it's not infinitely many solutions either. So we know it is a one solution. What is the next step? To determine which equation is equation 1 and which equation is going to be equation 2. So I'm going to call this equation 1. I'm going to go the other way around. So you can see that it doesn't matter. I'm going to call the first one equation 2. Okay. And I'm going to go back to finding the intercept in x first. I like to find the intercept in x first. Okay. So I'm copying my equation y equals 3x plus 2. By the way, we are going to have here fractions. Okay. So the intercept in x is when y is equal to 0. So I'm going to say 0 is equal to 3x plus 2. Now the 3x is added, it goes to the other side, subtracting because I need to have the x in one side. So negative 3x is equal to 2. Now I need to leave it completely alone, so the 3 goes dividing, and you carry the sign because the sign is part of the number, not of the operation. So x is equal to 2 over negative 3. You see, a fraction. So I'm going to copy that negative 2/3 over here. And just for the graphing purposes, I'm passing that into a decimal. So that will be negative 2 divided by 3. It will give me 0.666666666. But I'm going to leave it in 0.6, comma, 0. Now the intercept in y is when x is equal to 0. And I need to find the value in y. So I'm going to have y is equal to 3 times 0 plus 2. And 3 times 0, that's 0. So I cancel that out. Sorry about that. Cancel that out. And now I'm going to have that y is equal to 2. Okay, now let's go with the second equation. Equation number 2. Equation number 2 is y is equal to 4x plus 1. Also, we're going to get a fraction in here, okay? We're also having a fraction in here. Let's find the intercept in x. Remember, the intercept in x is when y is equal to 0. So 0 is equal to 4x plus 1. So I need to leave the 4x in one side. It goes subtracting. I have now negative 4x is equal to 1. Now the 4x goes to the other side with an inverse operation, which is a division. Remember to carry the sign as well, okay? So x is equal to 1 over negative 4. And that negative 1/4 is the one that I'm placing over here. Also, for the graphing purposes, I'm passing it to decimal. So this is negative 0.25, comma, 0. Now let's find the intercept in y. Intercept in y is when x is 0. To find the value of y. So we get that y is equal to 4 times 0 plus 1. And 0 times anything, that's 0. So I cancel that out. So y is equal to 1. And there, I have my points that I need. Remember, we determined already that this is going to be one solution. Okay, we determined that already. So let's move this a little bit to this side so I can graph it properly. Now the green one, negative 0.6, comma 0. Okay, so negative 0.6. This is, I use a scale of 2 squares. So it's a little bit past the half. Okay, that's 0.6 negative. And 0, comma 2 on the y. So 1, 2. And you can notice every single space between one number and the other has two little squares, okay? Every single one of them, not just one part and then the other one goes one again. Oh, every single one. And I connect those with a straight line, okay? So I'm going to connect that with a straight line passing through the center of both. And I extend it a little bit, okay? To both sides, it doesn't matter. Extend it. There. Okay, now I go with the second one, with the blue one, okay? And we got negative 0.25. So negative 0.25 is around the half of the half. Around there, okay? That's 1/4, one part of 4, okay? And 0.1, so over here. And again, I'm gonna connect those 2 points with a straight line passing through the center of both points. And I extended it a little bit as well. I draw my arrowhead. And how many solutions did I have? One solution, right? Exactly what I told you that we were going to have. So yes, it doesn't matter that sometimes our, somewhere around there, right? That's in red. There is where it connects, okay? Hi, me confundí. Give me a second. Here, that's it. In red, somewhere around there is a connection, and that would be my answer. One solution. You don't need to prove it. You don't need to do anything else, but tell me how many solutions it has. And we are going to see this topic next school year, where we determine the solution, but with other methods. Because in the drop-in, sometimes it is an approximate, especially when we have fractions, okay? So that's why we're gonna do it this way. Any question, guys, about the systems of linear equation? No questions. Okay, in our next class, we're going to see the review of systems of linear inequalities and obviously just linear inequalities. With that, we finish review day 2.